Hello, I'm Bartu Hamarat, and I am a Physic 102 student in Bilkent University, and I'm in Mechanical Engineering department. In this video, I'm going to present my Physic 102 project experiment. The aim of experiment is the finding the internal resistance and terminal voltage of a battery in DC circuit, and I'm going to use an ammeter, a voltmeter, a battery, and a set of resistors with no resistance. We are starting our experiment by measure the exact resistance values of our resistors to get more precise results in our further calculations. Because we do not have many resistors with different resistance values, I create 7 different equivalent resistance values by connecting only the approximately 100 and approximately 150 ohm resistors together in various series configurations. At this stage of the experiment, I connect a 100 ohm resistor to the battery. Then I place a voltmeter in parallel with the resistor and an ammeter in series with the circuit. This is the basic setup I use to measure the voltage across the resistor and the current flowing through the circuit. I then repeated the same circuit using the other 6 equivalent resistor combinations. For each setup, I recorded the terminal voltage and the current in the table you see on the screen. After collecting all the data, I used the values in the table to create a voltage current graph. We draw this terminal voltage current graph to determine the battery's internal resistance and its electromotive force. Using the linear form of the loop rule, stated as the terminal voltage equals the electromotive force minus the current multiplied by the internal resistance, we plotted the measured data and performed a linear regression. From the best fit line, the slope corresponds to the negative value of the internal resistance, and the y-intercept corresponds to the electromotive force. According to the regression results, the internal resistance was found to be 2.47 ohms, and the electromotive force was determined to be 1.504 volts. The internal resistance is slightly higher than typical values for small commercial cells, likely due to the measurement uncertainties, contact resistance in the circuit, resistor tolerance, and relatively narrow range of measured voltage values. Overall, the experiment successfully demonstrated how the internal resistance and electromotive force of a real battery can be determined using basic circuit measurements and the linear analysis of terminal voltage versus current.